Welcome, class. Today we're diving into buffer overflow attacks, repudiation, intrusion, traffic analysis, DDoS attacks, and spam. Let's start by understanding what exactly a buffer overflow attack is. A buffer overflow, or buffer overrun, is a widespread software vulnerability. Simply put, it occurs when a program tries to store data in a buffer more than it was designed to hold. This results in a buffer overflow. Hackers can exploit this to make a victim's program run malicious code. These attacks often target specific programming functions, where data is typically stored in the heap memory, while function return addresses are usually kept in the stack. In C, the strcpy function can inadvertently write strings longer than the buffer size. Now, let's examine the diagram on the right of our slide. This illustration shows us. Here we have the target address in memory, and this is the buffer's upper memory address. This part represents the heap in our buffer, and this is the stack. Our program's buffer is located within the heap, while the return address is stored in the stack. This is where the function's return address is stored. If an attacker overloads the heap with data, it overflows into the stack, overriding the function's return address. With the entry point of the attacker's malicious code. This means when the function call returns, it will execute the attacker's code instead, successfully completing the buffer overflow attack. Let's break down the stats of a buffer overflow attack. First, the attacker locates a program vulnerable to buffer overflow. This includes programs using functions without boundary checks, like string copy and string cat in C, which don't limit input size. Next, the attacker injects malicious code into memory. They then calculate the precise string length to overflow the buffer. The attacker then executes the buffer overflow, overwriting data beyond the buffer and altering the return address. This forces the program to run the attacker's malicious code. To defend against these buffer overflow attacks, we can employ two main strategies. First, implement strict boundary checks on buffer inputs. For instance, we should use string copy and string cat, which are buffer limiting functions. Another approach is adding sentinel values in the compiler to catch buffer overflow attacks. Now, let's explore the concept of repudiation. Repudiation occurs when data owners deny creating or sending data, or claim they never received specific information. They might attempt to prove they never sent or received the questionable data. To counter repudiation attacks, we employ identity authentication as a defense mechanism. Moving on, let's discuss intrusion. What exactly constitutes an intrusion? It's when unauthorized users access others' computer systems, exploiting weaknesses in system setups and protocols, and exploiting software vulnerabilities to illegally break in. Intrusion detection is a technique for identifying unauthorized access. Closing unused network ports significantly reduces the risk of intrusion. IP and port scanning are crucial tools in a hacker's arsenal. IP scanning locates active IP addresses on the internet, revealing which devices are currently online. Port scanning determines which ports are open on these active IP addresses. MAP, an open-source tool, is widely used for IP and port scanning. Now, let's explore traffic analysis. Traffic analysis is the process of examining IP packets to identify communicating parties and their data volume. IP headers reveal the source and destination addresses of communications. Transport layer port numbers indicate which applications the parties are using. Before P2P apps became popular, we could identify apps using port numbers. This method worked really well. So, how do we protect ourselves? we need to encrypt the whole IP message. But the encrypted header can't reach its destination. So we need to use a gateway. So, what's a gateway? A gateway is a special computer placed at the entrance and exit of a local network. All devices on the network must use it to talk to the outside world. Let's see how we send encrypted IP packets through a gateway. As shown in this diagram, IP packets must be routed through a gateway to reach their destination. Let's examine the process step by step. Step 1. Send the IP packet to the gateway. Step 2. Gateway A encrypts the entire IP packet, adds a new IP header, and forwards it to the next router. Step 3. The IP packet is transmitted from Gateway A to Gateway B. Step 4. Gateway B removes the IP header, decrypts the IP packet, and sends it to the recipient. This completes the process of transmitting encrypted packets via gateways. Now, let's turn our attention to denial of service attacks. What's a denial of service attack? It blocks legitimate users from accessing normal network and computer resources. There are two types, DOS and DDoS attacks. So what's a DOS attack? It's an attack from a single computer. And a DDoS attack. It stands for distributed denial of service. An attack from multiple computers. Let's look at an example of a DOS attack. A smurf attack is a classic example of DOS, and it's a sneaky way to attack indirectly. Here's how it works. First, the attacker spoofs the target's IP address as the source, and rapidly floods a network of computers with ICMP ping requests, as shown here. The attacker sends ping requests to numerous servers, using the victim's IP address as the source. Following the ICMP protocol, the servers receiving these pings respond to the spoofed source IP address. In this illustration, we observe servers receiving pin messages flood the target with pin messages. Consequently, the targeted host must rapidly process an overwhelming number of pin messages, leading to system overload. This is why we describe smurf attacks as killing with a borrowed knife. Now, let's examine DDoS attacks. Let's analyze a typical DDoS attack and its stages. To begin with, the attacker uses a control server to scan for vulnerable networked devices. They exploit vulnerabilities to infiltrate these systems, installing malicious software. These compromised devices become zombie hosts. Subsequently, the control server orchestrates these zombie hosts to simultaneously launch a DDoS attack on a single target. Now, let's examine how this process begins. Attackers need to take control of numerous zombie computers. These compromised machines then flood the target with SYN ACK packets in a short time. This is a classic move in a DDoS attack. Now, let's shift our focus to spam. What exactly is spam? Spam is basically unwanted messages that clog up your inbox, often containing ads or promotional content, or sometimes dangerous phishing attempts. While spam's main goal isn't to damage your computer, it doesn't directly attack your system, but it still eats up processing power and bandwidth. It also wastes users' time sorting through and deleting these messages. To combat spam, we need spam filtering software to prevent unwanted emails from reaching users' inboxes. The topics we've covered include buffer overflow, repudiation, intrusion, traffic analysis attacks, denial of service attacks, and spam. That concludes our discussion on these topics.